Hi friends, welcome to Easy to Learn channel. In this video I am going to explain about the microprocessors and microcontrollers. So before going to the topic, first of all we know about the what is a microprocessor and what is a controller. What is the difference between these two? So microprocessor is nothing but it is an IC. IC is nothing but integrated circuit. That means which contains all the functions of a central processing unit of your computer, and the microprocessor is also called as a processor or a CPU. That means we already know the heart of the computer system is a CPU. So in the same way CPU is nothing but a processor. So here the main examples of these microprocessors are nothing but these processors which are used in computers, laptops and mobile phones. So here the microprocessor inbuilt the microprocessor which is having a CPU. A CPU is nothing but central processing unit, arithmetic and logical unit and some registers. So the total CPU, ALU and registers are nothing but a microprocessors. Whereas, so these microprocessor, if you interface any external memory or we have to interface externally. So there is no inbuilt in this processor. So here we have to interface ROM, RAM, serial interface or timers or IO ports. We have to interface to the microprocessors externally. Whereas coming to microcontrollers, microcontroller is one of the controlling device which is incorporated in a microprocessor. That means microprocessor is a part of your microcontroller. So here this is a microprocessor. This is the part of your microcontroller. So this is also available in IC, so which is designed for specific operation in an embedded systems. So here the microcontroller which also consists of ROM, RAM, timers and IO ports and serial interface. So all these different peripherals which are inbuilt in the microcontroller. So this is a microcontroller. So all the peripherals which are inbuilt, that means the design of microcontroller which consists of all these parts. Whereas the microprocessor we have to interface externally. So if you interface, for example, if you interface any sensor to the microprocessor. So here the microcontroller which consists of ports, inbuilt ports. So which consists of microcontroller have 4 ports. So we have to interface any external sensors or any devices. We have to interface externally through ports. So port is nothing but if you see a computer system, there is a CPU, right? So this CPU which consists of four ports. Front 2 ports and back side is 2 ports. USB ports. That is nothing but if you connect any pen drive or any mobile phone, you have to connect. So we have to use those ports. So in the same way, if you connect external devices to the microcontroller, we have to use ports. So these ports are inbuilt in the microcontroller. So whereas in microprocessor, there is no ports. So for that we have to use, there is a microprocessor. So in this microprocessor, so we have to use PPI, Programmable Peripheral Interface. So 8255 IC, and we have to interface external devices. That means in between processor and external devices, we have to use one more IC for interfacing. So that is not there in microcontroller. That is one of the major difference between the microprocessors and microcontrollers. So here the ROM, RAM or any parts, here we have to interface externally to the microprocessor. Whereas in microcontroller, all these are inbuilt in the controller, inbuilt in the IC. That means, so all are designed in inbuilt. So if one more example, in 5 years or 7 years back, So we are used to mobile phones. We have to interface a memory card externally. There is some port which is given for the SD card. So nowadays there is no SD card. All the memory which are inbuilt in the mobile phone in the processor only. So here these processors and microcontrollers are mainly used in computers, laptops, and whereas microcontrollers are used in washing machines, refrigerators, air conditions. All these are the applications of microprocessors and microcontrollers. So here some of the features of 8086 microprocessor. Here the microprocessor which we are using here is 8086. So this is the IC number. 8086 is the IC number. See, it's an IC. So we are using the processor that is 8086 microprocessor. So coming to the features. The features of 8086 microprocessor are, it is a 16-bit microprocessor. That means it supports only a 16 bits of data. So it has 16 data lines and 20 address lines. It has 16 data lines and 20 address lines, and it has 2 power 20. If you find the memory based on the address locations, we have to find the memory, that is 2 power 20 is equal to 1 MB memory. And it has a power supply of 5 volts. And it is available in a dual inline package DIP. It is a 40-pin IC. That means the IC which is available in markets is like this. So this is an 8086 microprocessor. So which consists of 1 to 20 and 21 to 40. So these are it is a 40-pin IC. The IC is look like a dual inline package. So we have different types of packages that are available in ICs. So that is 40-pin IC. Now the next point is, it is operated in two different modes. One is minimum mode and maximum mode. So minimum mode is nothing but it uses only a single processor. So in minimum mode we have to use only a single processor, where in maximum mode there are more than one processor. That is a maximum mode. More than one processor. So, and it is available in the clock frequencies of 5 MHz, 8 MHz and 10 MHz clock frequency. And it also consists of 16-bit registers. There are different registers are there in 8086, all the registers of size 16-bit. And it also supports a pipelining architecture. So here the pipelining is nothing but, so we have different instructions. That is nothing but, for example, this pipelining architecture is nothing but, so here which consists of fetch, decode and execute. Fetching means we have to take the instruction and decode it and execute. For example, 8086 consists of different instruction. I am taking 3 different instructions. First one is add, second one is move, and third one is inc. So there are 3 different instructions. First, I have to fetch the instruction add. So here this fetch, which consists of what? Add, right? After fetching the second instruction, if this instruction is sent to decode, here is add and this is move. Next, this is execute. So for the next instruction, that is, so here is increment, inc, and the move which comes here, and the add will execute. This is add instruction, and the add instruction is executed, and move instruction is decoded, and inc instruction is fetching. That means all these 3 steps are executed parallelly. So this we call it as a pipelining process. So all these are the different features of 8086 microprocessor. Now